Now let's talk about what do you mean by dr equals to 0. What is the relevancy of dr equals to 0 practically or mathematically? The relationship between the bit error rate and the diversity order is in the terms of SNR. Specifically, the asymptotic SNR analysis you have used to evaluate the diversity order of a wireless communication system. This bit error rate is inversely proportional to the SNR raised to the power dr. So if dr equals to 0, what would be the BR curve with respect to SNR? Is the SNR will going to affect the bit error rate value at dr equals to 0 according to this mathematics? No, BR would be a constant line, right? Hence, all the antennas are used to provide the multiplexing gain or data rate. Hence, the bit error rate is a constant in case of higher multiplexing gain. However, at the other end, at r equals to 0, at r equals to 0, what would be the d? D would be maximum, right? And what will be then bit error rate? Then bit error rate would be decreasing with respect to SNR due to the high exponent power in negative. So bit error rate decreases with respect to SNR at r equals to 0. Why? I am repeating this thing. At r equals to 0, D would be maximum. D would be anything according to the communication system. It would be 2, it would be 3, it would be 4 or 5. So in that case, S bit error rate will decrease as SNR increases. So at r equals to 0, all the antennas provide diversity gain, right? We achieve the maximum diversity at r equals to 0. So in this 2 points, we have seen that how the bit error rate is related to the diversity gain and the rate gain. Now let's talk about some interesting examples. Let's say we have a 3 cross 1 meso system looking to transfer 101 bit stream. We choose this particular scheme where at the first transmitter antenna transmitting 1, second 0 and third 1 at a first time interval. So what would be the rate gain and the diversity gain for this particular system over this scheme? So according to the formula, R is min NR NT R would be 1. As I told you, the maximum parallel channel, maximum point to point channel would be 1, either from transmitter 1, transmitter 2 or transmitter 3. It means receiver would achieve only one bit at first time interval, right? And what about diversity gain? Do we achieve diversity gain here? No, right? So think about it. Why the diversity order is 0 using the previous examples, and try to solve this particular example where the 3 cross 3 system transmitting 101, first time interval 11, second time interval 00, and third time interval again 11 across all the transmit antennas.